Okay. Good afternoon, students. Welcome to the Real Analysis live lectures. So today we will see what is a relative metric, what is open ball in relative metric space, as well as what are boundary points. Okay. In previous lecture we have seen what is limit point, right? Interior point, limit point, and what is the closure of a set. Okay. So first I will define what is relative metric. Relative metric space, we can say. So let MD be a metric space, be a metric space, and a subset of M, and a subset of M. Then a metric, then this A inherits the same metric D by restriction of D. Restriction of D. We say it is D dash. Okay. Then A inherits a metric D dash by restriction of D. That is, what is D dash? D dash is nothing but D restricted to A. And this A D dash is said to be relative metric, or is called relative metric of metric space MD. Metric space MD. MD is our original metric space. Okay. M is here like this, you can see. Suppose this is your whole space M. Then if we take any subset A of M, then same, this is MD. If D is a metric on M, then D will be metric on A also, right? D will be metric on A also, and that means A together with that D is called as relative metric of M. Just we are restricting that D to subset of M. Okay, so we are saying it is a relative metric space, or we say this A D dash is nothing but AD only, because the metric is same, function is same, only set we are restricting. Okay, so this is called as a relative metric space of original metric space, our MD. Is that okay? Okay, now we will see what is mean by a open ball in with respect to this relative metric. We'll define now. First we will write a remark and then we will define. Okay, let's write a remark. AD dash will be denoted by AD. Okay, because metric function is same. Now we define open ball in AD. Open ball in relative metric space AD. What is mean by open ball? Okay, so let's 1 second. Open ball in AD. For any x in A, open ball for any x in A, open ball about x and radius epsilon greater than 0 is denoted by b epsilon of x in A, b epsilon of x in A, and is defined by b epsilon of x in A is nothing but set of all y in A such that distance of xy is less than epsilon. Is that okay? It's the same definition but just with respect to A. Okay, set of all y in A for which distance of xy or yx you can say. Usually center we write here. Let me write here. Center is x, so distance of yx is less than epsilon. Now this I can write as A intersection set of all y in M for which distance of yx is less than epsilon. Can I write like this? Because A is a subset of M, right? So what is this? This is nothing but, this set is nothing but what? Open wall in M, right? So it is just b epsilon of x. Open wall in original metric space we just define as b epsilon of x, and if we want to restrict it to relative metric, then we write it as b epsilon of x in A, where A is a subset of M. Is that okay?
Yes, sir.
So open wall in relative metric space is nothing but that set intersection open wall in original metric space. Okay. So next we will have a theorem. I will state theorem. A set, or first let MD be a metric space, and A is a subset of M. Then first a set G containing A is open in AD, open in relative metric space AD, if and only if G is equal to A intersection U for some open wall, for some open open set U in original metric space MD. We can say M in MD. And on similar lines, we can have second statement, a set F contained in A is closed in AD if and only if what? It should be F can be written as A intersection some C, where C is some closed set in M, for some closed set C in MD. Okay. So first we will prove it is if and only if statement. Proof. So what is given? G is open in relative metric space, and we have to prove G can be written as A intersection U for some open set U in MD. Okay, so suppose it is not empty, G is not empty. Suppose if it is empty, how can I write? Empty, every empty set, empty set is open. If G is equal to empty, yeah, can you see the screen?
Yes, ma'am.
Yeah. Yes. So if this G is empty, then can you give me a open set in MD which can be written as A intersection U? If G is equal to empty set is open. So can you give me an open set in MD for which I can write A intersection U?
A complement.
So if A is open, what about A complement? I want that open. I don't know what is A. I want to write empty set is equal to A intersection U. What U should I choose? Which is open set in MD? What should be that U which is open in MD? Again, empty set will work.
Yes, ma'am.
Whatever may be my A intersection empty is empty set, right? So, and we know that empty set is open in metric space, any metric space. So, for empty set it will work only. It is trivial. Okay, now we want to prove if it is not empty. Okay. Let me erase this. Suppose G is non-empty. Which is containing A, which is open. Suppose G subset of A which is open. Now I want to show G can be written as A intersection some open set which is open in M. So let X belongs to G, and since G is open in A, what will happen? There exists epsilon greater than 0 such that by definition of open set X belongs to B epsilon of X which is totally containing G. But this is with respect to A, right? Open ball in A. Is that right? Yes. So what this implies? G can be written as union of B epsilon of X such that B epsilon of X is contained in G. Can I write like this? Because for X is arbitrary point, X belongs to G. For every X in G, I will have some open ball. And this union of open balls will be nothing but my G, right? So this G I can write as union of, now what is B epsilon of X in A? This I can write as A intersection B epsilon of X, just open ball in M. I can write what is B epsilon of X is open ball in metric space MD. Is that right? B epsilon of X in A can be written as A intersection B epsilon of X. So this I can write as A intersection union of B epsilon of X. I can write. And what is union of this B epsilon of X? A intersection U, where U is nothing but union of B epsilon of X. Can I write like this? And we know that union of open balls is open. Every open ball is an open set, and union of open sets is again open. So which is open. Is that right? Where
Yes, sir.
U is open in MD. Okay. So conversely we have to prove. Conversely, suppose G is equal to A intersection U, where U is open in M. M or MD you can write. Okay. Now what I want to prove? My claim, or what I want to prove? G is open in A. I want to prove G is open in A. So whenever I want to prove some set is open, how I have to start? Start with arbitrary element in that set. So let X belongs to G. Is that right? So what this implies? X belongs to A intersection U, because G is nothing but A intersection U. G is nothing but A intersection U. So if X belongs to G, X belongs to A intersection U. Is that right?
Yes,
So this implies X belongs to A and X belongs to U. Now what is U? Where U is open set, open in M. Therefore what will happen? Therefore there exists epsilon greater than 0 such that B epsilon of X is contained in U, because U is open in M. Is that right?
yes.
So what this implies? What this implies? A intersection B epsilon of X is in A is contained in A intersection U, right? Instead of A, I will write letter this, because just you take A intersection with this. Okay. So X belongs to this, X belongs to U also. Now if I take A intersection with this set, it will be contained in A intersection U. Is that right? And that is nothing but, this is nothing but my B epsilon of X in A, which is contained in A intersection U, but it is nothing but my G. Is that right? So X belongs to B epsilon of X in A, which is containing G. So this implies G is open in metric space A, T. Is that okay?
Yes, sir.
So second part on similar lines you can prove. What is second part? If F is closed set, instead of open you have to take closed. So a set F contained in A is closed in metric space AD if and only if F is equal to A intersection C, where C is some closed set in original metric space MD. So for this what you have to do? Let F be a closed set in metric space AD. Then F complement will be open in AD, right? So use first theorem. So F complement can be written as A intersection U, where U is open in M, right? And then you can take that C is equal to U complement. That will work. Is that okay?
Yes, ma'am.
Okay, so second part you take as homework. Using first, you can easily prove. Second part, just you have to take complement of that. Second homework. Or I will write here, prove this. Okay, so now we define boundary points. We have already defined interior point, limit point of a set. Now we define boundary points of a set. Boundary points of a set. So let A is subset of M. Then any point x in M is said to be boundary point of A, boundary point of A if every neighborhood of X intersects A and its A complement and A complement. Every neighborhood of X intersects A and A complement. That is, what is neighborhood of X? It is just B epsilon of X. Intersection of A is non-empty, and what is B epsilon of X intersection A complement must be also non-empty. This is for every epsilon greater than 0. Okay, so and the set of all boundary points is denoted by the set of all boundary points of A is denoted by bdry of A. So how can I write? That is, bdry of boundary points of A is nothing but set of all x in M such that B epsilon of X intersection A is non-empty and B epsilon of X intersection A complement is also not empty for every epsilon greater than 0. Can you see the full screen, whatever I am writing?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay, so you can imagine this. Suppose this is set A. Suppose this is my set A. What are interior points? These are nothing but all these points, whatever yellow color. These are nothing but interior points of A, right? And what are boundary points? Boundary points are nothing but whatever denoted by green. This let be color different. These are nothing but all are boundary points, because if I take this X, it whatever neighborhood if I take, it will intersect A and its complement. Okay, this is my whole metric space MD. This is my M. This is my A. A is any subset of M. Then what X is said to be boundary point if every neighborhood intersects A and its complement. What is A complement? What is A complement? It is nothing but this. This is whatever I am highlighting with lines. This is nothing but A complement. Is that right? So every neighborhood of X intersects A as well as its complement. Then that point is said to be boundary point of A. So all these whatever are there, all these are nothing but boundary points. Okay. Can you understand this? Okay. So for example, or we'll have a remark. A remark. First, A is equal to 0, open 1. Then what are the boundary points of A? What are boundary